So, quick recap. We understand now that there's a machine on planet Earth that's smarter than a human. In our case, we used a cat engine to demonstrate that. Then we understand that we're going to have to be an AI first company. We're going to have to put AI into every single one of our proposals, or we're going to lose them all. And then third, we talked about how to implement AI inside your business. You want to do it open source. You want to keep it inside your company, and you want to empower your employees. Don't take AI directly to the customer yet. Use it to supercharge your current employees. Now, before we turn over our company to artificial intelligence, it might pay for us to understand what a deep neural network is. So let's scaffold down into this and just talk about it at a very, very high business level. So over on the left, you have an input layer. Now this input layer is whatever you're feeding it. You're feeding it text, you're feeding it economic data for the CEO, you're feeding it operational data on your infrastructure. It doesn't matter, you're feeding the data into the left side of the neural network, and it's going to take it and break it into its smallest little bits. Then it's going to move through some hidden layers. And these hidden layers are going to try to process. You've got your output layer over on the right, which is your desired output. And then you have all this input data on the left. And what these hidden layers are going to try to do is get you to the correct output. And again, remember in the cat engine, we ran out from that shelf and asked the humans, hey, is this really a 9? Yes, that's a 9. Is this a cat? Yes, that's a cat, etc. We're going to have a way of testing whether this deep neural network is actually working and we're getting the right results. Okay, so here's a very, very basic example. We have this 9. Imagine you wrote it on a check and you took it to your bank and they want to understand what the check amount was. They break it down, 784 pixels. Every single input is a single pixel. So all they're doing is taking this image of a 9 and they're saying, look, if it's a black box, if it's a black pixel, make it black. If it's a white, make it a white, make it a 0 value. And then what's really interesting about artificial neural networks is they can handle gray. So they can handle a value between white and black. Now this is really interesting. I'm going to digress for a second, but the human brain cannot do that. So even though the human brain has infinitely more neurons than any deep neural network on Earth right now, the human brain, the neuron is either firing or the neuron is not firing. It's either a 1 or a 0. In the case of artificial networks, they can handle something between 1 and 0, and this is why you're seeing such extraordinary capabilities right now in these, what it would be considered in human brain terms, very tiny neural networks. Okay, digression over. So we're going to send the black pixels, the white pixels, the gray pixels, everything. We're going to send it into the input, and then maybe the first hidden layer, and again, this is very metaphorical. We don't do this way anymore, but it's a great example, is we're going to break this 9, or the whites, right? The whites and the very, very light grays. We're going to light them up, and we're going to break them into smaller parts. Here's a horizontal line. Here's kind of a couple vertical lines. Here's something that looks a little curved, a couple 45-degree lines, whatever it may be. This first hidden layer is going to try to make sense of all 784 input layers. Okay, now the second layer hands it off to the third layer. And the third layer says, okay, I'm going to put this back together again. Thank you for identifying what's white and light gray. Thank you for looking at the different component parts of what's white or light gray. But now I'm going to try to piece it back together, and what I basically see is a loop up top and a vertical line below. Now, if I saw 2 loops, I would think it's an 8. If this wasn't a loop, I might think it's a 7. If there was no loop at all and just a vertical line, I might think it's a 1. You get where we're going. And then finally, this last layer hands it off to the output layer, and the output layer says, look, I think this is a 9. Now, I'm about to make my second digression, right? I digressed here up in the gray because that was very important, but it's very important here too that this is just a guess. An artificial network is probabilistic. So in a way, it may not be 100% sure that this is a 9. It's just saying, I know there's no way it's a 4. So I'm super confident it's not a 4. It does have a loop, but I don't think it's a 0, right? The loop is closed, right? You know, if it was open, I might think it's a 7. So really, in a way, all these work together to come out with a probabilistic answer to say, look, based on what you gave me as outputs, I'm not positive this is a 9, but I'm a lot more confident it's a 9 than an 8. And I'm definitely confident there's no way it's a 4. This is where the hallucinations come, by the way. This is why you get hallucinations with such confidence, is because this output may beat this output by a very, very tiny bit, and it's just giving you the wrong answer. By the way, this is another reason you may get two different answers from a chat GPT, because every time it runs through this, sometimes one output may score higher than the other. You do it again, then this output scores higher than the other. It's constantly changing. Okay, digression over. Now, the only thing red on this entire graphic is this up here, and this is extraordinarily important. Because what happens is this neural network is horrible when it's first run. So somebody sits down and says, let's build a neural network. Let's put this many hidden layers. Let's put this many inputs. Here's our output. Here's what our desire is. Okay, try to guess and see if that's a 9. Oh my gosh, you're horrible. Right? Try to guess a 5. Oh my gosh, you're horrible. You're horrible. You're horrible. You're horrible. Right? And so what ends up happening is we tell the neural network it was supposed to be a 9 and you thought it was a 4. You so blew it. Oh my gosh, bad neural network. Well, what the neural network does is it computes how bad it was. It gives itself a grade. And based on how bad or good that grade is, it's actually going to go backwards. So it's going to say, oh my gosh, we got an F in getting that 9. Go back, and what I want you to do is I want you to tweak your calculations in this layer. Because something in this layer is firing at such a high level. It's saying 4, 4, 4, 4, 4, and we know it's not a 4, we know it's a 9. You got to subdue that. And then this other one that could really help us get to a 9 is kind of quiet. It's not firing much at all. We need it to fire more. So what it's going to do is it's going to go back and it's going to change the weights of the layer right behind output and say, look, can I turn these knobs a little bit and can I get to a 9? And then guess what? That layer is then going to go back to the previous layer and it's going to say, look, man. So obviously the output layer says, I need a 9, don't give me a 4. Quit giving me a 4, I'm getting upset. So this layer is going to say, I got to give this guy a 9. We got to stop giving him a 4. And that says to this layer, look, you're responsible too. I need you to turn your dials and turn your weights a little bit too. Now this thing runs millions and millions and millions of time, forward and backwards. Shoomp. Oh, F grade. Shoomp. Okay, try again. Shoomp. Oh, you got a 5. I don't know if that's any better than a 4. Shoomp. Change all the weights. So what it's doing, and this is why it requires all those little video cards, the tens of thousands of video cards, because it's constantly going back and forth and back and forth. And honestly, in a way, the humans back in the library, they've already done their job. Because what they've done is they've looked at 1,000 different ways to write 9, and they said, this is a 9, this is an 8, this is a 7, etc. So the neural network already knows when it's right or wrong. It can grade itself based on human input. But now it's trying to tune itself to where it always gets a 9. Now again, I'm going to make one more digression. It never is sure of a 9. Again, I cannot emphasize this enough in that neural networks are probabilistic. Honestly, the human brain is probabilistic, right? You and I can look at two different scenes and we might see something different. We can read two different sentences and we feel something different, or we think we understand something different. Okay, let's keep going. I know that's a lot of detail. Now, okay, so let's start talking about these large language models. Now, I used an example of a 9. I used a very, very basic example to walk us through a deep neural network. But these large language models are 175 billion parameters. Now, this is GPT-3. We don't know what GPT-4 has because it's proprietary. 70 billion is sitting in Llama 2. Each one of these parameters is a different calculation. It's calculating in these neurons to tune it a little bit to get it just perfect. Now, the other interesting part of this is all these commercial providers, they hide all their tunings. So they're constantly hiding their tunings so that nobody outside their company can see just exactly how this neural network works. Llama 2 and these open source ones, they're like, we'll tell you exactly how we did it. We'll tell you exactly how we tuned that neuron. We'll tell you exactly how we tuned that. And this is going to become very, very important in a second. Okay. So 7 billion models are not good enough. It's not an advanced, and people will argue with that, but I just don't think a 7B is good enough. I think you need to at least get up to a 70B, even if you're going to add a bunch of your own data. There is a brand new model out of France, which is very interesting, and it's actually 8 different 7B models. So this is kind of like the mixture of experts. It's like walking into a boardroom and no one in the boardroom is a genius, but there are 8 people sitting around the table. You ask a question and they debate it amongst themselves and they come out with kind of a consolidated answer. So in this case, you might use a 7B. You just need 8 of them in this particular model. Okay, so down to large language. So large language data has 96 hidden layers. So again, we don't know GPT-4 because they lock that completely down. Well, of course we don't know Claude, we don't know Bard, none of these commercial providers are going to tell us anything. But there's 96 hidden layers in GPT alone, GPT-3 alone. 96 plus the input plus the output. Let that sink in. 96. That is absolutely mind-numbing. And this is why it costs $100 million to train a GPT. Is because you have all these hidden layers, you have just infinite number of inputs, you have to constantly be tweaking and going back and forth and changing the weights between these layers, et cetera, et cetera. Now, what does that mean for your company? Well, the first thing you've learned is that you do not want to spend $100 million. You do not want to roll your own GPT from scratch. Eventually you will, but right now you don't want to start out with a blank hard drive and say, hey, build me a GPT just like OpenAI. And remember, where's GPT-5? Where is it? Where's Meta Llama 3? Well, these things take months, right? If not a year to generate. These are massive models. Dubai's working on another model, a Falcon. Meta is churning away. GPT-5 is already churning away, et cetera, et cetera. Now, what do you do as a business? You do these red things, okay? And again, this is going to take a second. In fact, I think I'm going to come back for a part 2 because this red is where your data actually starts getting implemented into the large language model.